7th grade, Chapter 5, Section 1, Algebraic Expressions. Starting off with our vocabulary, so variable is a symbol that represents an unknown quantity, like X, N, A, B, or C, or any letter in the alphabet. An algebraic expression, such as n plus 2, is an expression that contains variables, numbers, and at least one operation. So it could be n plus 2, n divided by 2, n times 2, n minus 1, n minus 2, any of those, as long as it has a variable, a number, and an operation. Algebra is a branch of mathematics that involves expressions with variables, which is what we're doing, what we're getting started with. Coefficient is the numerical factor of a multiplication expression that contains a variable. For instance, 2 times x, the coefficient is 2, the variable is x. 101x cubed, the coefficient is 101, the variable is x cubed. 93b squared c to the third, your coefficient is 93, while your b squared c to the third is your variable. If you're going to define a variable, it is when you choose a variable to represent an unknown quantity. For instance, if you need to know how many miles you travel in a day, well, you don't know that right off the bat, so you put in maybe x for that, and you take other information from your problem and find out how many miles you travel in a day. Getting started with our quick check here, divide right in simplest form. So 1/10 divided by 1/5. Remember, when you divide by a fraction, you have to multiply by its reciprocal. So we have 1/10 times 5/1. We'll cross reduce, and we'll get 1/2. 4/7 divided by 3/8 becomes 4/7 times 8/3. Nothing to cross reduce, so we end up with 32/21, or 1 and 11/21. First, we have to turn it into an improper fraction, so we get 3 times 6 is 18 plus 1. So we get negative 19/6 times 9/4. 3 goes into both of those. And then we multiply across. So 19 times 3 is 57. And 2 times 4 is 8. A negative times a positive is a negative. 8 goes into 57 7 times. So we get negative 7. What's left over? So 8 times 7 is 56. So we have 1/8 left over. So negative 7 and 1/8. We get negative 3/5 divided by 4, negative 5/2. So that's negative 3/5 times negative 2/5. And there's nothing to cross reduce, so we get negative times negative is a positive. 3 times 2 is 6. 5 times 5 is 25, and we leave it at 620. In 3 hours, the temperature dropped 13.5 degrees. On average, how many degrees does the temperature drop per hour? So in the question, they're giving you a clue. How much did it drop per hour? So per hour, so it's degrees per hour, or degrees over hours. So I'm going to put 13.5 divided by 3. And the first thing I'm going to do is I'm going to turn that 3 into a fraction by putting it over 1. And I'm going to turn 13.5 into an improper fraction. So 13 times 2 is 26 plus 1. So we get 27/2 divided by 3/1, which becomes 27/2 times 1/3. And I can cross reduce. I get 9/2, which is 4, with 1 left over. And the 1 goes over your divisor. So 4.5 degrees per hour. 4.5 degrees per hour. How can you use numbers and symbols to represent mathematical ideas? That's what we want to think about as we go through this chapter. Today we're going to learn to evaluate algebraic expressions, to define variables, and to write algebraic expressions. So our vocabulary, which we talked about earlier, was variable, algebraic expression, algebra, coefficient, and defining a variable. So make sure you know those. We'll need them for our tests and our quizzes. Evaluate 2 parentheses n plus 3 if n equals -4. The first thing you're going to tell me to do is replace the n with -4, which as you can see they did here in step 1. So you get 2 parentheses -4 plus 3. So you start with PEMDAS. You go inside the parentheses. -4 plus 3 is -1. Then you do your multiplication. 2 times -1 is -2. So again, the first thing we're going to do when we evaluate is replace. So we get 3 parentheses 6 minus 4. Then we do parentheses inside the parentheses first. So we bring down the 3. We haven't used it. Times 6 minus 4, which is 2. 3 times 2 is an answer of 6. Evaluate 8w minus 2b if w equals 5 and b equals 3. So here we have 2 things to substitute in. When we substitute them in, we get 8 times 5 minus 2 times 3. There's no there's nothing to do inside the parentheses. There's no exponents. That takes us to multiplication. 8 times 5 is 40. 2 times 3 is 6. And then we can do the subtraction of 34. To try one on our own, we would substitute in first. So we get 6s is 4 minus 3 times -2. There's nothing to do inside the parentheses. There's no exponents, so I go to multiplication. 6 times 4 is 24. Then I say I have -3 times -2 gives me a positive 6. Okay. Remember that goes with the number. 24 plus 6, we can do the addition now, and we get 30. Evaluate 4y cubed plus 2 if y equals 3. So the first thing that we have to do is plug in the 3. But you notice we have that cube, so we have to go back to what does cubing something mean. It means that we are multiplying it times itself, the base times itself 3 times. So 3 times 3 times 3 is 27. Then we do there's nothing to do inside the parentheses. There's no more exponents. We do the multiplication. 4 times 27 is 108. Plus 2 gives us 110. Evaluate 3m squared minus 4 if m equals -3. So the first thing I do is plug in. So I have 3 parentheses around what I'm plugging in. Plug in that -3. Put my squared up here, minus 4. I have nothing to do inside the parentheses, so PEMDAS. Then I have exponents. Well, I do have exponents. Remember that -3 squared is -3 times -3. 2 negatives make it positive. 3 times 3 is 9. So I get 3 times 9 minus 4. Moving down PEMDAS. After exponents, we have multiplication. 3 times 9 is 27. Bring down that 4 I haven't used. Now I have subtraction. 24 minus 4 is 23. The formula for rewriting a Fahrenheit temperature, I got one ahead. Athletic trainers use the formula 3 parentheses 220 minus a close parentheses all over 5, where a is a person's age, to find their minimum training heart rate. Find the trainer's minimum training heart rate if she is 15 years old. So you have her age, which is A equals 15, and you plug it in. So 3 times 220 minus 15 over 5. You do what's inside the parentheses first. 220 minus 15, 205. Then you take the fraction, you do the numerator on its own, and you do anything in the denominator on its own. It's almost like that's a parentheses of its own. You could almost think of it as putting it like this. So you have extra parentheses around it to show that you have to do all of that information first. So we do 3 times 205, and we get 615. Then we divide 615 by 5, and we get 123. So Latrina's minimum training heart rate is 123 beats per minute. So the formula for rewriting a Fahrenheit temperature as a Celsius temperature is 5 parentheses Fahrenheit minus 32 over 9, where F equals the temperature in degrees Fahrenheit. Find the Celsius equivalent of 77 degrees Fahrenheit. So C equals, plug it in, 5 parentheses 77 minus 32 over 9. So the first thing we do, we look inside for parentheses. So 77 minus 32. 77 minus 32 is 45. Rewriting everything we haven't used. C equals 5 parentheses 45 divided by 9. Write it down. Do your multiplication. 45 times 5 is 225 over 9. Then I do the division, and I get C equals 25 degrees. So C is 25 degrees Celsius. Here we have our units. Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 each week. So write an expression that represents the total amount of money Marissa has saved after any number of weeks. So I'm going to ask you to look for two things on these problems. I want you to look for something that's used one time and something that's used multiple times. In this case, what's used once is she's already saved that $25. Okay, that's not changing. That's what she started with. So that's one time. Then, an additional $10 each week. That each is giving you a clue. It's telling you that you're doing it multiple times. That is why they write it as 10 times W, because you're using W over and over again. So we can write it as the expression, what we started with, $25, plus what we're adding to it each week, 10 times however many weeks we are, whether we're going for 2 weeks, whether we're going for 100 weeks. That's how much we are going to be saving. Trying one on our own to make an expression. Leah has already read 20 pages. Well, she's already read 20 pages, so that tells me we're only using it the one time. She plans to read 5 pages each day. So that tells me with that each in there, that's a good clue that I'm doing that multiple times. So since my 20 is used once, and my 5 pages, I don't know how many days, I'm going to put 5D because it's 5 pages each day. So day 1, she did 5 pages. Then after 2 days, she had 10. After 3 days, she had 15. So it just depends on how many days they ask for. Write an expression that represents the total. Total means we are getting a larger number of pages she will have to read in D days. So I'm going to say 20 plus, since we needed to get a total, plus is good, times 5D. Refer to example 5. Will Marissa have saved enough money to buy the $150 DVD player in 11 weeks? Use the expression 25 plus 10W. That's the one that we came up with before. To put in 11 for our weeks. So we replace the W with 11. We get 25 plus 10 times 11. 25 times 110, which is 135. So Marissa will have saved $135 after 11 weeks. Since $135 is less than $150, she will not have enough money for the DVD player. The expression 25 plus 5D represents the total number of pages Leah will read in D days. Will Leah read more than 60 pages in 7 days? So will she read more than 60 pages, okay, for that 7 days? I'm going to take my expression 20 plus 5D, where D stands for days, and I'm going to plug in that 7. And I'm going to start using PEMDAS. So I have 20 plus 35, so that's 55 pages. 55 is not greater than 60. So will she have read more than 60 pages? No. In 7 days, she will not have read more than 60 pages. So how did what you learned today help you answer the question, how can you use numbers and symbols to represent mathematical ideas? Well, today we learned to represent unknown values with variables, and to represent real-world situations with algebraic expressions. So then you can describe a real-world problem with a variable or variables. Be sure to define your variable.